are multiple ways of looking at parabolas. In other words, we were taught, or you were taught, that that's your basic format.
Yeah.
That's a parabola, like this. It's a function, it passes the vertical line test, and all kinds of things.
Uh-huh.
And now all of a sudden you're studying conic sections, correct?
What's that?
Conic sections, there's 4 kinds. There's circles, parabolas, ellipses, and hyperbolas.
Oh yeah, I don't think we've talked about that.
Okay, well, one of them is the parabola.
Yeah.
But this is a new kind of parabola now. This is a parabola that has a focus and a directrix.
Uh-huh.
The focus is somewhere in there, and the directrix is a horizontal line that is equidistant from the vertex. In other words, however far away the focus is from the vertex, the directrix is that same distance away.
Yeah.
And in fact, we have a whole new definition for parabola. A parabola is a set of points that are equidistant from the focus and a line drawn vertically or perpendicularly to the directrix. Of course, these two distances are equal, no matter where we're at on the parabola. If I'm up here, then the distance from the focus to that point is the same as that point to the directrix. Okay?
Yeah.
What is the general form of the parabola that they have taught you? Because different school systems actually use a different system. I'm guessing it's this.
4p?
No, you use C.
We use C. A equals 1 over 4c.
Ah, then you don't use that.
Yeah.
You use this, and A equals 1 over 4c, c being the distance to the focus.
Uh-huh.
Okay? So, if I gave you a parabola in vertex format, what is the focus? Where is the focus located? First of all, where's the vertex? Let's start with the vertex. Let me draw the correct picture of it. Where's the vertex?
It's at 3, 4.
Okay, let me make that a point right there. 3, 4. Does it open up or down?
It opens up.
Okay, so that's kind of what we're looking at.
Uh-huh.
And we want to solve for that point and this line.
Yeah.
So A is 2. So A equals 1 over 4c. What does c equal to? Plug in for A and then solve for c.
Okay.
So 2 equals 1 over 4c, because this was A. And now solve this equation for c.
Wouldn't it be 1 over 8?
Yeah. In other words, I multiply both sides by 4c, so I have 8c equals 1. So c equals 1/8. Okay? That makes this distance from there to there 1/8. So what are the coordinates of the focus?
Wouldn't that be 3 and 4 and 1/8?
Yes. What is the equation of the directrix?
Wouldn't that be 3 and 3?
Okay, now first of all, the equation of the directrix is the equation of a line. And in this case, it's a horizontal line, so it's got to be y equals something.
Wouldn't y equal 3 and 7/8?
Yes. And there's your directrix and focus.
Okay.
Okay? Now, the other thing about these kind of parabolas is that you can rotate them so that they're no longer a function. In other words, you can have horizontal parabolas also. In other words, if I take my normal looking parabola and turn it like that, that's not a function, but that is x equal y squared instead of y equal x squared.
Yeah.
The way I kind of memorize this is that the one we were taught from the beginning is y equal x squared, and that's the one that's either vertically up or vertically down.
Uh-huh.
Well, this is change the variables. In other words, it's the y that's being squared, and it's equal to x, and that's what we're looking at here. And notice that's not a function, but it is a relation. And it has a focus and a directrix, perpendicular to its line of symmetry.
Uh-huh.
And you figure it out pretty much the same way by letting a equal 1 over 4c.
Yeah.
And in this case, it's the a that's in front of the y squared.
Yeah.
Okay. Let me go back to the notes here. So, focus and directrix, we know how to do parabolas in intercept format, vertex format. Let's talk about increasing and decreasing intervals.
Okay.
Where is that function decreasing? On what interval? You use interval notation?
Yeah. Yeah.
So it's decreasing on what interval?
Point to the screen where it's increased.
Right here.
Where the range of x values starts.
X is greater than...
Speak up.
X is greater than 0?
Well, I'll just tell you here. It's decreasing from negative infinity to 0. Notice it's decreasing all the way from as far left as you want to go on the x-axis.
Okay.
In other words, this means it goes like that forever.
Uh-huh.
Okay? So it's decreasing from negative infinity all the way to this point on the x-axis, at which it flattens out. And
Okay.
then it starts increasing. In other words, from here to there, it's always increasing. So it's increasing on which interval?
0 to infinity?
0 to positive infinity. And parabolas only have two parts. One is always decreasing, the other half is always increasing. If you had a cubic function, in other words, if I gave you a function, and you'll be getting cubic functions pretty quick, like that,
Mm-hmm.
let me label this. Where's this function increasing? What interval?
Negative infinity to negative 1?
Good. And on what other interval?
And 1 to infinity?
Where's the function decreasing?
Negative 1 to 1?
You got it. And that's, in other words, you can get as complicated as you want depending on how many different loops you have in the function. But as far as quadratics go, quadratics are always parabolas. So they're either that or they're that. Well, in this case, you're increasing from negative infinity to that point, and decreasing from that point to positive infinity. And the reverse of that. All right, let's look back at some more practice with all types of factoring quadratics. Okay? Now let's start with an easy one. Solve that equation for me.
Wouldn't it be x minus...
Okay, x and x. In other words, that's always my first step, is to put the two things that create that. In other words, you got to break that up into two things. Second step is to figure out what the signs are. What are the signs going to be?
It's going to be a plus and minus.
Right, because it takes opposite signs to create a negative 6. And now what?
It'll be a plus 2 and minus 3.
Okay, so you can do the basic simple ones. If we get more complicated by adding a thing there, let me think for a moment. Let me see if that works. One second, I'm going to do the math in my head here to try to... Okay, I believe that will factor. All right, so these obviously are a little tougher. Whenever it's a coefficient in front of the x squared.
I'm sorry, can you repeat that? Sorry, my dog was barking.
That's okay. Yeah, whenever there's a coefficient in front of x squared, it makes factoring a little tougher.
Yeah.
And the reason is that when there was no coefficient, we could use all those nice little sayings like factors of the constant that subtract to the coefficient of the middle term, or factors of the constant that add to the coefficient of the middle term. Well, the moment you go away from x and x, you can't do that anymore. And it becomes more trial and error, to be honest. I don't know how you've been taught this method. If you've been taught something called the California method or the Diamond method or one of those, that's fine. I personally prefer my method. It's a lot faster, a lot quicker, and less confusing. And I generally teach people my method rather than teaching the more confusing California method.
Okay.
Let me just go through my method with you, and I'll let you decide which you want to use, which technique. Okay, so first thing I have to do is determine the signs. And this is unique because that is no longer the same as this. So I have to allow for both. Okay. Now I'm looking for factors of 12, obviously. Well, we got 12 and 1, we got 4 and 3, we got 6 and 2. So I can use any of those. And I would automatically say to a student in Colorado that start out with the factors that are closest together. In other words, I'm not going to start out with 12 and 1. I'm going to start out with 4 and 3.
Okay.
And I'm going to just do them randomly. I'm going to start out trial and error. Does that produce a middle term of minus 5x? And to check, all I have to do is multiply the two inside terms and the two outside terms. Well, this is plus 4x. This is minus 6x. That gives you minus 2x. So that's not correct.
Yeah.
Now, if I move the 4 down to here and the 3 down to here, it would give me the same number, but the other sign. In other words, it would give me plus 2x.
Yeah.
So I don't want to even try that. That's a waste of time. But let's try 3 there and 4 over here. And what does that give me? Plus 3x minus 8x. That produces my middle term. That's the way I factor. If I couldn't find a solution with using 3 and 4, then I would go back and try 6 and 2, and then I would finally try 12 and 1.
Okay.
And I'm 100% convinced that this method is better than the diamond method.
Okay.
Only because it's quicker. It gets to the answer quicker. And they don't give you really, really hard ones. In other words, maybe Chatfield might, but they're not going to give you something like this. Why? Because there's so many different factors of 24 and that 24. We'd be at it all day trying to factor it.
Yeah.
So they may give you more complicated ones, but they're going to be on the order of this level of complicatedness, I'm thinking.
Yeah.
And so if you can figure out how to factor that kind of a quadratic by whatever method, if you're good with your diamond method, then don't let me get in the way of that. But I don't use it. I use my method. And then, of course, to solve it, what do you do? Most important rule of algebra says that if you multiply two things together and they equal 0, one of them has to be 0.
Yeah.
So the next step is to set that equal to 0 and solve, and set that equal to 0 and solve. So if 2x plus 3 equals 0, what's x equal?
Negative 3 over 2.
And if x minus 4 equals 0, x is equal to?
4.
So those are your two solutions. You almost always have two solutions with a quadratic.
Okay.
Okay? All right. Why don't we stop with that session there?
Okay.
That gives me an idea. Let me just take a quick peek at what the third one says. Using and interpreting the discriminant. We can cover that real quick. Do you know the quadratic formula? By heart?
No.
Yes.
Yes, I do.
I was going to say, if you don't know it, you need to learn it. Especially at Chatfield. What is it?
Minus, the quadratic, okay, sorry. Minus b squared plus or minus the square root of b squared minus 4ac all over 2a.
Let me help you memorize this. I consider it made up of two parts. There's
Okay.
the first part. What else is that? Minus b over 2a.
Isn't that like for the
Vertex, that's the x coordinate of the vertex. In other words, another way to solve for the vertex is to use minus b over 2a. If you have a quadratic in standard format, then just put minus b over 2a and you'll have the x coordinate for the vertex. So if you have that memorized, it helps with the quadratic and vice versa. Okay?
Yeah.
And then the rest that makes it easy to memorize is this thing here inside the radical has its own name. It's that important. And the reason it is because it's quite useful to analyze that before attempting to solve a quadratic, because that will tell you whether you have real solutions or imaginary solutions.
Yeah.
Notice that if b squared minus 4ac, that's the discriminant, not the square root of that, but that's the discriminant right there. If that's positive, you're going to be taking the square root of a positive number and you're going to have real answers. If it's negative, you're going to be taking the square root of a negative number and you're going to have two imaginary answers. If it's exactly equal to 0, well, this term goes away and you end up with minus b over 2a, which is one answer only, and it's real. So equal to 0, one real answer. Greater than 0, two real answers. Less than 0, two imaginary answers.
Okay.
And that's everything you need to know about the discriminant. Except how to spell it. I didn't spell it right. It's discriminant. Like that.
Okay.
Okay? All right. So, Bob, are you still there?
I am.
Okay. We can go forward however you like. I can turn you loose and let you... you've made it to my website and scheduled this session, right, on your own? Yeah. That's what the green means, yeah.
Right.
Is that you scheduled it. So you know how to do that, and you can certainly do that for future sessions if you like.
Right.
If you know right now that you want a session on Friday night at 8, I can make it for you a little bit easier than you can by just going in here and entering it. So I'll let you tell me if you want to talk it over with Emily and figure out, you know, what's the best time to have sessions. Feel free. You can do hour sessions or half-hour sessions. Even beyond the first session, you can choose to do half-hour sessions. I actually have a lot of my students doing half-hour sessions now. They do 2 half-hour sessions in a week rather than 1 hour session. It breaks it up a little nicer. Makes it it gives them full focus for a half hour instead of partial focus for a full hour. You know what I'm saying?
Right. Yeah.
Whether that would apply to Emily or not, I have no idea. She may not have any problem at all focusing for an hour, so I will let you guys decide that also.
Yep.
I have recorded this, and I will send a copy of it tomorrow. It takes all night to process these files, and I will send a copy to your email, Robert, as to how she can look at the recording of this. And that's that. So.
Okay, that sounds good.
You have any other questions or anything?
No, I think what I'd like to do going forward here is I'm going to talk to Emily a little bit.
Okay.
I think we'll want to do 1 or 2 more sessions.
Okay.
Yeah, I realize they'll be paid sessions.
Okay.
And, you know, I'm going to talk to her and kind of, you know, get some feedback and stuff. And then I think our next session will be at least a week away, because right now basically her marching band just ended and she's playing a little bit of catch up.
Okay. Just a word of warning, my Wednesdays are usually pretty packed, and Tuesdays and Thursdays. Monday through Thursdays, pretty packed, although if she was looking for a session, she'd easily be able to find it now. But if she waits until next Wednesday, there may not be anything open. So
yeah, we're pretty flexible on what nights it is.
Okay,
so
cool.
Not a problem.
And I almost always have half-hour slots open. Yeah. So you could always get a half-hour slot in if you wanted to.
Yep.
Okay.
And given that you live so close to us, we may try a face-to-face as well.
Yeah, that's fine. I'm happy to come to your house. You could come to my home where I work out of my office. We can do anything you want. Or we could meet at Columbine Library. It's sad. We both live close to Chatfield High School, but there's no library close to Chatfield High School. At least not one I'm familiar with. So.
Yep.
Okay?
All right.
All right. Well, nice meeting both of you, and I will talk to you later.
All right. Thank you.
Thanks.
Bye-bye.